Welcome back to Pinkfish Inc. Today I'm going to go over the simplest example for Pinkfish. So first, open a console, and then we're going to go to the Pinkfish directory and run Jupyter Notebook. We'll open the examples directory, and buy and hold, and strategy. Okay, at the same time, I'm going to open another tab and change into the Pinkfish subfolder, which has the backend code for Pinkfish, and use a text editor to open up those files because we're going to refer to them in a little bit. So going back here, let's look at the basic structure of this notebook. The basic structure is we do the imports, and I use the alias PF for Pinkfish when I do the Pinkfish import and all the examples. We set a format for the prices, so we use 2 decimal places after the decimal point, and we set up our global data. We set the symbol, the capital to $10,000, the start date and the end date. The start date and the end date are used to select the trade period. However, we actually download all of the pricing data for SPY from Yahoo Finance, and that dates back to 1993 for SPY. It differs based on the symbol, but we download the entire thing, and then we select the trade period with start and end. The next thing we do is we actually do the fetch. For Pinkfish, there's 4 basic things that happen for the time series before we actually do the algorithm. We fetch the time series, we select the time series. There's a missing step in this algorithm because it's so simple. We add technical indicators, and then we finalize the time series. So the first step is the fetch. Okay? The fetch, when we call it, we pass in the symbol and we get back the time series. The time series is a data frame. So I will use TS a lot in the examples, and you can just know that that's the time series represented as a data frame. The next step we'll do is the select trade period, and it's just like it sounds. We pass in the time series, the start and end date, and then we specify whether we want to adjust for dividends and splits or not. So if you set it to false, it's not going to adjust for dividends and splits. Okay, the next step is we're going to finalize the time series, and that just kind of does some cleanup of the time series and just make sure that everything's sane before we try to run an algorithm on it. These functions are all found in the fetch.py file. We can find those in here. Here's the fetch. You can see there's some additional parameters, and they have default values. You normally don't have to concern yourself with these. Normally you can just pass in the symbol here. The one that you probably may want to change sometime is this one, the use cache. If use cache is true, it's only going to fetch this one time from Yahoo Finance, and then it's going to use the cached version and put it in a CSV file from that point on. After a few days, you're going to want to update that. So to update that, you're going to include this parameter, use cache, and set it to true. And that will get you a fresh copy of the CSV file. Alternatively, you could manually go in and just delete the file out of the cache directory. In this case, spy.csv. That's a little hackish, though, to do that sort of thing. It's better just to set this use cache value. In fact, one thing we could do to remind ourselves that that is available is we could put it in here and have it available. So use cache is equal to true. And then when we want a fresh copy, we set that to false. Okay, so that's one thing we could do. All right, I do that in a lot of the other examples. I was just trying to keep this one as simple as possible. All right, the other parameters, like I said, aren't nearly as important. You can specify where your CSV file goes. The default is data. In fact, if you set up a cache directory, that's where it's going to go. It's going to go into your cache directory. You can, in fact, specify what your from date is for Yahoo Finance, but I really suggest that you just don't use that, and you should just get the entire time series in most cases. The next step, the next function that was called was a select time period. In this case, we're just passing in the time series, the data frame once again, the start date, the end date, and whether we want to adjust for dividends and splits. Whether you want to adjust for dividends and splits really depends on what you're after. That's kind of beyond the scope of this video to talk about that. But I would just say in general, if you're doing a long-term strategy, you want to include the dividends because that will give you a fair representation of what your returns would be. If you're taking your entire capital, making a trade, and then reinvesting the entire capital into the security, that's what you're doing with dividend reinvestment. If you're doing some kind of short-term trading strategy, and in particular, if you're basing it on prices, certain price levels, then if you're using adjusted, you might not represent things very well. Whereas in that case, you might want to use adjusted equal to false. And lastly, like I said, this is the Finalize time series, and you can see that it's getting rid of NaN, rows that have NaN values in it, and it's adjusting the start, stuff like that, cleanup type operations. Okay, the next step we're going to do is we're going to create the trade log and the daily balance log. We're going to trade, those are objects that we're creating. So these are classes. Trade log is a class, and daily balance is a class. And those are both in trade.py. Let's go to the top here. The trade log is at the top, and then the daily balance is near the bottom. There's the daily balance class. So we create those objects. Then what we're going to do is we're just investigating. We're just doing a TS, so that lets us investigate the time series. We can look at it and make sure everything looks normal, makes sense. If we were using adjusted closing prices, we would notice that the adjusted close and the close would be the same thing. In this case, you see they're not. We're not using adjusted closing prices. And if we're using adjusted prices, these would all be different too. They would change based on the relationship between the close and the adjusted close price, the proportion between those. Then we move on to the fun stuff, the algorithm. First step is to set your trade log cache equal to your capital available. And then we're going to loop through the time series one row at a time. Now, this is where Pinkfish differentiates itself. Most backtesting Python libraries do not allow you access to the time series in this way. They usually provide a callback function for you to get one row at a time. But this is a much more powerful way to do things. But with power comes responsibility. So you can make errors with this sort of strategy. But in this case, the programmer has more power. You have more capabilities here, and that's why why I did Pinkfish, so that I could have uh, more capabilities. Okay, so these two are kind of boilerplate. You're going to want to do these two every time. You get the date and you set the end flag. The end flag will either be true or false based on whether it's the last row or not in the time series. And by the way, we're looping through each row at a time, and each row is getting converted to a tuple. I did some performance testing, and this by far is the fastest way to loop through a data frame, and that is to convert each row into a tuple. It's so much faster. I have a notebook that demonstrates this. Next, we set up the buy logic. So we simply check to see if we currently have any shares, and if we don't, we do a buy. So trade log.buy, we pass in the date, and we pass in the price that we're buying at. So we're buying at the closing price. But we could just as well have bought at the open price. And here's where Pinkfish will let you do unrealistic things, really. You could also specify row.high or row.low. Now, obviously, you don't know you have no way of buying at the high or buying at the low. So you just have to know that's not something you can realistically do. But you can realistically buy at the open or buy at the close. And then sell, what we're going to do is just check to see if it's the last row. And if it is, we're just going to sell the entire position. So, and then for each time through the loop, we're going to record the daily balance. In order to record the daily balance, we need to pass in the date, the high of the day, the low of the day, and the close of the day. And those values will be used to compute, based on the number of shares that we have, what our daily balance is, our high balance, low balance, and closing balance for each day. So how does this work? Well, let's pretend we're on row number 1. We come through, the date is set, and the end flag is set. The end flag, the date will be whatever the date is for the first row. The end flag will be set to false because it's not the last row, it's the first row. So then we'll do the buy, and then we'll record the daily balance, and then we'll loop through for the second row. We'll come in, we'll get the date for the second row. The end flag will still be set to false. And then we'll skip over this since we have shares now. And we'll skip over this since it's not the end flag. And then we'll record the daily balance. So we'll just keep looping through here, recording the daily balance over and over and over until finally we get to the last row. Okay, and then the end flag becomes true, right? And then because the end flag is true, we'll sell our position. Now, let's briefly go look at the buy and sell functions. And those are in trade.py. So those two functions are actually aliases for enter trade and exit trade. So let me look for those. I'll show you what I mean by alias. Okay, so you can see buy is it's just a reference to this enter trade. Okay, so here's the actual function, enter trade. And what we do is we pass in the entry date, the entry price, and the shares. If we pass shares equals to none in, it's going to use all of our available cash. And that's what we're doing. Since we didn't specify that parameter, it uses all of our available capital to buy as many shares as we can. Okay, so that's all I want to look at for this one. And then the other one is exit trade. Let me go down a little bit. And you can see there's an alias set up for that. So sell is the same as exit trade. So exit trade is, it takes the exit date, the exit price, and again, shares. If you set shares equal to none, What it's going to do, it's going to sell every share that you currently have. So that's the way that works. Go back to here now. Now that we're done with all of our trading, we're going to come down here and retrieve the logs. We retrieve the trade log and the daily balance log. Now, these are objects, right? And then these objects, we call this function, and these functions return data frames. So what happens is these right here were basically references to class objects, and then they get replaced by this. This is just the way I wanted to do it. But you end up losing these references to these objects here. If you want to maintain those, you need to call these something different, like this, like t is equal to t log, like that. Okay, so that's just kind of a programming technicality. I like to do this sort of stuff sometimes in Python. You get a lot of flexibility to change your references. In one instance, they might be an int. The next instance, they might be a string. That sort of stuff. I'm pretty comfortable doing that kind of thing. So, anyway, little side note. Anyway, we look at the trade log, and what we see is we're not surprised. There's only one entry. All right, so let's go through each one of these things. So what is in the trade log? Well, for each trade, and there's only one here, there's the entry date, the entry price, the exit date, the exit price, and then this is the profit lost points. So this would indicate a profit for this trade since it's positive. That's the profit lost cash. That's the quantity is the number of shares for that trade. The cumulative total is the total sum of each of the trades combined. In this case, we only have this one trade, and for the first row of the trade log, these are always going to be equal, right? But if we had more rows on here, the cumulative total is going to change. It could go up or down. Hopefully, you've got a good algorithm and it trends up the entire time. The direction of this trade was a long trade, and the symbol is SPY. Lastly, is we get into analysis, and that's when we get the stats. You always have to call this function the same way. So we get the stats, and we get the stats by calling pinkfish.stats, and we passed in the time series, the trade log, the daily balance, and the capital. Okay, so then once we do that, we're able to call the summary function, and we pass in the stats, and we get the summary. Before, I want to go and look at these two functions, and then I'll come back to this. So those are in stats.py. And I'm looking for, statistics.py, my bad. Okay, the first one that it's called is stats. Okay, stats is going to go out and compute all the statistics in one go. Okay, I didn't want to have it to where you had to call a bunch of different functions to get different types of stats. Stats computes everything, and then you decide what you want to display after that. So it computes all of this stuff. Okay, and then after you call that, then you can use summary, and this summary function is very flexible to display all kinds of stuff. And so let me go through the parameters. So you pass in the stats that we just computed, and then if you're using a benchmark, you would pass the benchmark stats in here, but that's defaulted to none. That means you're not using a benchmark. The metrics is, what metrics are you interested in displaying? And it's set to, the default is default metrics, which is this. So by default, these are the metrics that are going to be printed out. Of all those available metrics, those are the ones that are going to get printed out. There's also some other ones currency metrics. You could use that one as well. You can pass in your own custom set of metrics here. You just need to pass in a tuple like this with the things that you're interested in displaying. And the things I'm talking about, these metrics, any of these metrics. You can also use the default metrics, and then let's say you just wanted to tack on one or two other items onto here, you would pass it in here with extras. So if you're good with these default metrics, but you're also interested in seeing like the daily standard deviation, then you would pass that in, and you would have the default metrics plus the extra one, which would be this daily standard deviation right there. Okay, so let's go back here now. So you can see that it's printed that out. I'll go through each of these briefly. This is the annual return rate. That's the compound annual growth rate, CAGR. The max closed out drawdown, that's the peak to trough, and that's based on the closing values. The best month is not actually the best January, February, March, or April, etc. It's actually the best 30-day period. So it cycles through every 30-day period and tells you which one was the best one. Same thing for the worst month, it works the same way. Then we have the Sharpe ratio, the Sortino ratio, the monthly standard deviation, and the annual standard deviation. And that is a quick overview of the buy and hold example.